This video covers sections 7.1 and 7.2, and first we're going to cover section 7.1, in which we're going to talk about what a rational expression is. We're going to find values for which rational expressions are undefined. We're going to evaluate rational expressions. We will simplify them and also talk about what opposite factors are. So first of all, what is a rational expression? Well, it's an expression that basically has the form of a fraction. So it looks like some p over q, where p and q are polynomials. And of course the denominator, q, can't be 0. So what are some examples of this? Well, it could be something like 5 over x plus 6. We have a monomial over a binomial. It could be something like x minus 3 over x squared plus 5x plus 6. So these are just a couple examples of what rational expressions are. The very first thing we're going to do, now that we know what they are, is we are going to evaluate them. And we've done this with other types of expressions. So it says evaluate this rational expression, x squared minus 3x minus 28 over x squared minus 15x plus 56 for when x equals negative 8. And hopefully you remember what we do here. Remember, we're going to take this negative 8 and we are going to plug it in for everywhere there's an x. And what do we do when we plug in? Remember, the key to this is to put it in parentheses. Everywhere you plug in negative 8, you put it in parentheses. So this is going to look like negative 8 squared minus 3 times negative 8 on the top minus 28, and then that's divided by, again, negative 8 squared, because that's x squared, and then minus 15 times negative 8, and then plus 56. So we can go ahead and simplify this. Negative 8 squared is negative 8 times negative 8, which is 64. We have minus 3 times minus 8. Negative times a negative is a positive. It's 24, and then we keep the negative 28, or subtract 28, and then on the bottom, again, negative 8 squared is 64. We have a negative times a negative. 15 times 8 is 120. Then we add 56. Then we can simplify the top and the bottom again. 64 plus 24 minus 28, that's equal to 60. Divided by 64 plus 120 plus 156, that's 240. And 60 goes into 244 times. On the bottom, 60 goes into 60 once. And so this entire expression, this rational expression, when we evaluate it, simplifies down to 1 over 4. So that's how we evaluate a rational expression. We also want to talk about how to find values for which the rational expressions are undefined. So when we have a rational expression, we can't use values for the variable that make the denominator equal to 0, because remember, we can't divide by 0. Dividing by 0 is a no-no. We can't divide by 0. And so if I'm looking at this, I have this first example, x plus 5 over x minus 4. If I can't divide by 0, that means the denominator which is x minus 4, that cannot equal, I'm going to use a not equal sign there, that can't equal 0. And then if we solve for x, we add 4 to both sides. We can see that x cannot equal 4. So, if you take this and you go and plug it back in, we can verify that this is true. If I have x equal to 4, then I get 4 minus 4, and 4 minus 4 is 0, and I can't have the denominator equal to 0. So we can do the same thing in part B. This one's a little bit more complicated, but still we take the denominator, the x squared plus x minus 6, and we say that can't equal 0. That can't equal 0. And now we know how to solve this. We just did this at the end of chapter 6. We know that we solve by factoring, so this is x plus 3 times x minus 2 is not equal to 0. And then we take the plus 3 and we say that can't equal 0. Or the x minus 2, that can't equal 0 either. This gives us that x can't equal negative 3. And the other one tells us that x can't equal positive 2. In either case, we get divisible by 0. The denominator cannot be 0. Okay, so how do we simplify these to lowest terms? That's going to be the next topic in this section. In Chapter 1, we reduced rational expressions. You know, when we had something like this, like maybe 16 over 20, the very first way that you learn how to do something like this is you factor it. You say, okay, well 16, that's 4 times 4, and each 4 breaks down into 2 times 2. And so if I factor the top is 2 times 2 times 2 times 2. And then we could do the same thing for the denominator. 20 is 4 times 5. 5 doesn't break down, but 4 again, that's 2 times 2. So the denominator is 2 times 2 times 5. And then you remember what we did? We went and we divided out common factors. And so there's 2 factors of 2 that are common in the top and the bottom. Those divide out, leaving 1. And so when I simplify here, I very simply I get 2 times 2 on the top. 2 times 2, of course, is 4. And then on the bottom we get 5. So my answer, this simplifies down to 4 over 5. Later, of course, we saw, okay, well, we can divide that by 4 to get 4 and divide that by 4 to get 5. And that's kind of like a shortcut, but more simply put, what we're really doing is we're dividing out common factors. We factor and then we divide out common factors. And in this section, when talking about rational expressions, we're going to do the same thing. We're going to first factor both the numerator and the denominator completely. And then we're going to divide out the common factors. Same exact idea. So the last chapter becomes key. Chapter 6, where we learned how to factor, because remember, rational expressions have polynomials in the numerator and the denominator, so we have to be able to factor these out. So this will be a good review. In the numerator, we have a difference of squares. Remember how that factors? So this would factor to x plus 2 times x minus 2. And that's because the square root of 4 is 2. 2 times a negative 2 is a negative 4. And remember, with these difference of squares polynomials, if we were to check it by multiplying, the 2 middle terms cancel, which is why we don't have a bx term. And then on the bottom, again, we can factor here. We know we're going to have x and 2 numbers that multiply to give 8, negative 8, but add to give negative 2. That's got to be a negative 4 and a positive 2. Okay, I'm going to move pretty quickly with the factoring on these because this should be a review item. It also is a review for you, but it'll give you a chance to practice as well. So now, just like the example above, we divide out the common factors, and this brings me to x minus 2 over x minus 4. And now I always get this question. I get, okay, well, can I then take these x's and cancel those? Well, you can in this case. We can't do that. We can't cancel because the x's have the 2 and the 4 attached to them. It's like they're grouped with parentheses. So we're not going to be able to do that. We can't cancel. In fact, that's as far as we can go. My answer is just x minus 4 over, x minus 2 divided by x minus 4. We move on to the next one here. We have, on the top, we have 5a plus 15. And what's the first thing we always check for when we're factoring? We talked about this quite a bit. So the first thing we check for is the GCF. And in this case, we can pull a 5 out. If I pull a 5 out, I'm left with a plus 3. And then in the denominator, again, I can check for a GCF. I can pull a 10 out, which leaves a squared minus 9. And are we done? As far as we can go. Hopefully you see that on the bottom, we're left with the difference of squares on the bottom. I'm going to go ahead and highlight that so you can see what I'm talking about. That's a difference of squares. In fact, we know that that factors to a plus 3 times a minus 3. And now we're to the point where we can go ahead and cancel. We know that this a plus 3 will divide out with this a plus 3. And we know that 5 goes into 10 twice. So on the top, all I have is 1 times 1, because both factors divided. So that's 1. And then on the bottom, I have 2 times a minus 3. And that's your answer. I also have something similar for the next one. We pull out a GCF at the beginning. X times x squared minus x minus 2 over, pull out an x squared plus 4x plus 3. And after we pull those x's out, we still have some we can still factor what's left in the inside. This would be x minus 2, x plus 1. And then on the bottom we have x times x plus 3 times x plus 1. Cancel out the x plus 1s, cancel out the x's, and we're left with x minus 2 over x plus 3. Again, I'm going to remind you, we can't cancel out the x's here. This is as far as we can go. Example D. Again, we have x plus 3. That can't factor, but the bottom, that's a difference of squares. It's x plus 3 times x minus 3. The x plus 3's cancel, leaving what on the top? Leaves 1 on the top and x minus 3 on the bottom. We have one more example here of simplifying. Okay, this is a rational expression that has polynomials with 4 terms. You remember the method there? We want to factor by grouping. So if I look in this first group, I have a common x I can pull out, which leaves y plus 3. And then in the second group, I have a common positive 3 I can pull out. Sorry, not 3. What is it? Common 2, which leaves y plus 3. We do the same thing on the bottom. First group we can pull an x out, which leaves y plus 3. Second group we can pull a 5 out, which leaves y plus 3. You have to remember all these factoring methods. And this of course simplifies to y plus 3 times x plus 2 on the top. And on the bottom we have y plus 3 times x plus 5. What are my common factors I can divide? Well, it's the y plus 3's. So my answer is x plus 2 over x plus 5. This is how we simplify rational expressions. Now we can go ahead and move on to opposite polynomials. two expressions are opposites if they have a minus b and b minus a. In other words, they're the same two numbers, a and b, except the opposite numbers are, or the numbers have opposite signs. So here we have a negative b and a positive b. Here we have a negative a and a positive a. These are called opposites. And what's nice about opposites is once you've seen one of them, you know that when you cancel with opposites, you always have the same thing happen, and we don't have to do this first step every time. So I'm going to go ahead and on the top here, I'm going to pull out a negative 1. You'll see why here in a second. If I pull a negative 1 out, I know that changes the signs. This is negative x plus 7. You can check that by distributing. Negative 1 times negative x is positive x, and negative 1 times positive 7 is negative 7. And then the bottom, we still have 7 minus x. And then I'm going to rewrite the top. I'm going to rewrite this, the part in parentheses, I'm going to change and put the 7 first and the negative x after. And we have 7 minus x. And you see what's going to happen here? We have common factors of 7 minus x, and those cancel, and all we're left with here is negative 1. In fact, anytime you have opposite polynomials, you can always cancel them and add a factor of negative 1. Let's see how this works in an example. I have x squared minus 15x plus 56. Let's go ahead and factor that. That's x what? X minus 7 and x minus 8 over, and on the bottom we have a difference of squares, and it's a little different than the form we're used to seeing because the 64 comes first. Usually we have x squared first, so if 64 is first, that's going to be 8 times 8, and then x squared has to be x times x, and because it's negative, one has to be a positive and one has to be a negative. And so now if I'm looking at this, I can see, okay, there are a couple of opposite polynomials. It's the second two. It's x minus 8 and 8 minus x. They're opposites. X minus 8 and 8 minus x are opposite polynomials. So when I divide those out, remember I get a factor of negative 1. So I can cancel those and just have negative 1. And so what that does is it turns my whole answer negative. I'm going to slide the negative on the front. I'm going to have x minus 7 divided by 8 plus x. And there's my final answer. Okay, so now we're going to move on to section 7.2, and we are going to talk about how we can multiply and divide rational expressions. And it's much the same way we work with multiplying fractions. Remember that when we multiply, we want before we can divide out common factors. So 4 goes into 4 once, and it goes into 8 twice. And then once we do that, we just multiply straight across. So 2 times 3 on the top is 6, and on the bottom we have 11 times 1 is 11. So simplify first. Simplify first, and multiply across. Multiply straight across. So when we do that, let's take a look at what this looks like in this first example. If I refactor, remember if we want to simplify we have to factor, so the first rational expression is going to be x plus 2, x minus 1, and then in the denominator we have x minus 5, x plus 1, and then we go ahead and factor the second one. That's going to be x plus 9, x minus 5 over x plus 9, times x plus 2. And now we go ahead and look for those common factors. And you can cancel any factor on the top with any factor on the bottom. So right here, x plus 9s. Here we have x plus 2s. And lastly, x minus 5s. So all that's left is the x minus 1 and the x plus 1. So that's my answer. My answer is x minus 1 divided by x plus 1. Now, how do we divide two fractions? That's a slightly different story. When we divide two fractions, remember, we multiply by the reciprocal. So 8 over 11 divided by 4 over 7 is the same as 8 over 11 times the reciprocal, 7 over 4. Then we go ahead and simplify again. Then we multiply across. 2 times 7 is 14. 14 over 11. Same idea with dividing rational expressions. Instead of dividing, we want to multiply by the reciprocal. So I'm going to take this, the top, we can factor out a GCF on the first one, which leaves x plus 2. On the bottom, it factors to x minus 3 times x plus 2. And then this is going to be multiplied by the reciprocal. The reciprocal is the x squared minus 9. I'm just going to lightly write this on the top, and then we're going to factor it. So this is x, difference of squares, that's x plus 3, x minus 3. And then I'm going to write the other one. Remember, we're taking the numerator right in the denominator, so this is x squared plus 7x plus 12. And that factors to x plus 3 times x plus 4. So we're done with these. I just wanted to make sure we had the polynomials in the right places. And then we go ahead and again, just like we have been doing, factor out or divide out the common factors. We have x minus 3s, we have x plus 2s, we have x plus 3s. And so what we're left is, the only thing on the top is a 4, and the only thing on the bottom is an x plus 4. And again, I'm going to ask this question, can I divide out the 4s here? No, 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 no. We cannot do that. We cannot divide out the 4s because this 4 has an x attached to it. Okay, we have another example here. This is a multiply, so we don't need to do any flipping the reciprocal. So we'll factor out a 2, leaving a plus 5. On the bottom we have a cubed times a squared. Factor out a 3, leaves a plus 5. There's two a's here. This is like a times a. On the bottom there's 3 here. This is a times a times a. So if I'm multiplying those, I'm going to cancel 2 on the top with 2 on the bottom, leaving just a down here. And then we can also cancel out the a plus 5s. And so the only thing left on the top is 2, and then on the bottom we're left with a 3 and an a. And so this final answer is 2 on the top divided by 3 times a. We have couple of last examples. What I would like you to do is pause the video here real quick and go ahead and attempt these on your own, and then we'll come back and check your work. Alright, welcome back. Let's go ahead and check your work here. So x squared minus 9, that's going to be x plus 3 times x minus 3. That's a difference of squares. We've already done that a few times on this video. And we can think of this as over 1 anytime you want to turn something that's not a fraction into a fraction, we just put it over 1. And then we have x plus 2 over x plus 3. Are there any parts we can cancel here? You bet. We got x plus 3's. Those cancel. So what we're left with here is x minus 3 times x plus 2. And on the bottom we have 1. Do I need to write over 1? We could, but it's not really necessary. So we're just going to write x minus 3 times x plus 2. Then on the second one, again we factor. We have x minus 7 times x plus 5. That's this first fraction, numerator, first rational expression. And the second one, we have negative 15 and positive 36. That looks like x minus 12 and x minus 3. Okay, and then we're going to multiply by the reciprocal. It's going to be x plus 11 times x minus 3 on the top. That's taking this denominator, factoring it, and moving it to the top. And then we're going to take the numerator, factor it, and move it to the bottom. And we get x minus 7 and x plus 6. Almost done. Go ahead and factor out the common factors. We have x minus 3. We have x minus 7. Anything else? Doesn't look like it. So my answer here, this is x plus 5 on the top times x plus 11 divided by x minus 12 times x plus 6. And there you go. That does it. This is multiplying and dividing rational expressions. We'll see you in class. Thank you.